All right, in this topology, we have OSPF configured. OSPF area 1 is in a headquarters. Area 0 is DC and extended till the edge of headquarters. So the headquarters edge router is a ABR router. We have area 1 in the left on switch 101 and switch 102, and area 0 in the right. And if you notice, all the subnets of area 0 begins with 10.2, and all the subnets of headquarters begins with 10.1. If reachability is there, I should be able to ping from VPC 5 to VPC 7 and 8, and vice versa. Let's go and check that. I'll go and ping from VPC 5 10.2.70.7, which is VPC 7 on the right. So I'm able to ping from the headquarters to the head office. Likewise, let me also ping 80.8. I'm able to ping. Now I'd like to show you the routing table on R12, which is in area 0, data center. If you see there, the routes are seen detailed. All the subnets, or see all that starts with 10.1. I told you they're coming from area 1. All that is having 10.2, they are local. See, the local is having O. The other area is having IA, means having 10.1. Okay, in which we understand that they are not summarized, isn't it? 10.1. There are 5 subnets coming from area 0. We are verifying this, sorry, coming from area 1. We are verifying this in router 12, area 0. What is next? Next is, we have this reachability. We need to now discuss a scenario. Let's discuss in the offline, and then we'll. So we need to provide authentication. As I have written here, it should be SHA-3884, means, you know, the hashing algorithm should be this one. We all know that OSPF null authentication type 0, plain text type 1, MD5 or SHA is type 2. So we want the hashing algorithm to be SHA, not MD5. For that, we need keychain. And the key ID is 1. And the password is CC1 IE or I3. CCIE3. Let's see how to do this. First of all, create a keychain. Key chain. I'm going to say this is between headquarters hyphen DC. And then key ID is given. I have given there 1. Key string I have given there CCIE3. And next is algorithm. Cryptographic algorithm. So there's a option right inside the keychain itself. You see, this is what I have given you to use. All right. And then I need to call this simply under the interface. The keychain is ready. Do show history.
Right.
I'm going to paste this. I'm going to paste this on all the device. So I'll use this notepad. Later I'll use this. Okay. So what is next is I need to go under the interface. Interface Ethernet 00 IP OSPF
0, 0.
authentication. The keychain is HQ-DC. That's all. Authentication is enabled here, so I'll be losing my neighbor very soon. So this also I would like to copy to the notepad. Do show history. This push. See, the neighbor is expired. Okay, so now let us move on to the other switch, same configuration.
Mm-hmm.
Even here now again I'll lose the neighbor. Show IP OSP of neighbor. If you see the timer should go more than it's going less. You know, every 10 seconds, if the hello packets come, it should not go less than 30 seconds.
Mm-hmm.
Right? It should not go less than 30 seconds. But I can see it is losing this neighbor.
Right.
Yeah, it's losing this neighbor. It's almost gone. That's it. You see, this 11 is internal. We don't have authentication here. Okay. So I'm going to copy this again and put it
Right.
on other two switches on the other side. And now I am expecting neighbor to come up. Yes, it has come up. Even here, when I paste, I'm expecting the neighbor to come back. Yep, the neighbor has come back. And if I ping now, I should be able to ping from here like before. Fine.
Yep.
Now, authentication using keychain is over. See, this is like without changing the OSPF timer. You know, OSPF sends hello packet every 10 seconds, and 40 is the dead timer. Without doing any changes to this timers,
Mm-hmm.
we should be detecting the neighbor failure. If a neighbor fails in this redundant path, see, we got redundant path between headquarters and the data center. Say, for example, if this if it is failing here, let's say, if it fails here, OSPF will not go down so easily. The reason is the line protocols are still up because the switch is available. So OSPF will wait for 40 seconds to remove the neighbor. See, when the link goes down, the hello will stop coming, isn't it? Hellos will not come. So it takes 40 seconds for this switch
Right.
to take another path. See, there is another path, but to take another path, it takes 40 seconds. But we want it to be within 150 millisecond. 150 millisecond, not seconds, not even a second. And props need to be sent every 50 seconds. So what is this prop? This is the clue that we have what to use. BFD. BFD is a UDP based hello packets. BFD is a UDP based hello packets which are sent every time interval, and if BFD did not see the response to the hello for a period of time interval, then BFD will inform the protocol that neighbor is no more. I repeat, this BFD is a UDP based bidirectional forwarding detection, is a super fast protocol that detects the link failure in milliseconds, from 150 milliseconds. See, for voice traffic, if there is 300 millisecond delay, it is okay. So this can identify that there is an error in the path in 150 millisecond, so that OSPF can immediately swap the packet through another alternate path. See, we have alternate paths. You understood what I'm saying? So BFD makes this switch over faster.
Yes, sir.
But again, I want to tell you, BFD will not work alone. It works along with a routing protocol, but it is independent of any routing protocol. Do you get my point? It can work with OSPF, it can work with ISS, it can work with EIGRP, it can work with BG. See, it needs some routing
Right.
protocol to go and
Yes.
inform that link is failure. That protocol can be any protocol. So it provides a consistent,
Right.
timely failure detection. Consistent, like OSPF timer is 40 seconds, and every 10 seconds the hello packet neighbor will send. Sometimes some hello may be skipped because of congestion, something like that. But BFD is not like that. It's a tiny UDP based hello packet. It can provide consistent, timely failure detection. So the failure detection are in millisecond only. In 150 millisecond also you can identify that the neighbor has got some error. That fast is BFD. Okay, so we are going to consider switch 101 and switch 102 as the primary.
Mm-hmm.
Okay, and sorry, 101 and 201 as the primary.
101 and 102.
Switch 102 and switch 202 as the secondary. How do we achieve this?
Mm-hmm.
We can achieve by setting cost. Right now, I would like to go and check the cost on switch 101.
Mm-hmm.
Let me go to switch 102 now.
One.
Switch 201. Hello 201, where are you? Here. Show IP OSPF. Show IP route. OSPF. Okay, I can see here for 10.1.50 it is 30. I think I did not run any protocol. Yeah, I don't have any protocol running in between here. And I don't have any subnets. That's why I don't see other path. Okay, so let me go and add that interface, or we can also do without that interface. Fine. Let us first focus only on this probe. Okay, let us first enable BFD, and we will focus on BFD alone. Let's not get into the routing stuff, but when you do the lab, I recommend you to put some subnet here starting with 10.1, 10.2, and enable OSPF here.
Mm-hmm.
so that you will have both this path and as well as this path. Right now, it's not like this. It
Mm-hmm.
is this path
Right.
or this path.
Mm.
So if you wish to have this path, then you need to have OSPF here. I'm not going to have that, but you can try, you can use that when you do the lab. Now, I want the BFD to quickly identify the neighbor down.
Mm-hmm.
Right now, you see, in
Okay.
101, if
Mm-hmm.
you notice, I'm going to shut down this port, okay? I'm going to shut down this port. See how long it takes for switch 101 to know that. I'm going to go to switch 201 and shut down that port. Interface Ethernet 0/0, I shut down. Now I'm taking you to see 101 still did not know that neighbor is down. You see how long it has taken. Show IP OSPF neighbor. See, the timer should go 0, only then it will remove the neighbor. That's why we need what?
Mm-hmm.
BFD. Still the neighbor is not removed. Why I'm taking this long to show you this? After BFD, you will see the neighbor now gone. After BFD, you will see as soon as you shut down there, in 150 millisecond, it can tell that the neighbor is down, so that the switch can take the alternate path. Now, what I'm going to do is I'm going to trace route and show you. Right now, it is going to it will be going via switch
Right.
101 trace 10.2.70.7. If you see, it goes via switch 101. Do you agree this? Now I'm going to ping this. It's keep on pinging. Now I'm going to shut down once again,
Yes.
see how long it takes for the convergence. I've shut down, that's all. You see how long it's going to take? It's going to take 40 seconds. Why? Switch 101 is still thinking that switch 201 is alive. The neighbor is still maintained in the neighbor table. Only after the neighbor is removed, it can take the alternate route. Is that right? So we are waiting for the convergence, see how long it takes without
That's
BFD.
correct.
See how it pings. Now let me bring that interface up and we will enable BFD. So now the packets will switch back to the original
Mm.
path. Okay, it has gone back to the original path. That will come seamlessly. Now let's do BFD. The BFD can be enabled in a global level, can also be enabled in an interface level. I don't want global level. I just want the WAN facing interface, Ethernet 00 only.
Right.
Okay, so I'll go under the interface. IP
Mm-hmm.
OSPF, sorry, first let me enable BFD. BFD and interval, see 50 is the minimum. So what I have told you, the prop should be sent every 50 seconds. Can you go less than that? No. And then minimum
Right.
receive interval. minimum receive interval. That is also 50. Okay, I'm saying 50 is the minimum. Next, what did I say there? OSPF should detect the loss of neighbor within 150 seconds. So how many times of 50 is 150? 3 times. So the multiplier value is 3. Now you can see that BFD is applied on Ethernet 00.
3.
It is ready. Likewise, you can go to switch 201 and put the BFD there. Let me go and do that. Do show history. I'll put this one on switch 201. Before that, I would like to show you something else. You see, BFD is enabled, but what is the use? It is not tied up to any protocol. You see, show BFD neighbor. I don't see any neighbor. And nothing, because okay, let us go and configure the other side, then I'll come and show you. Go to switch 201, put the same command, BFD. I did not copy. Let me copy from switch. You want me to type? Okay. So I'm on Ethernet 0/0, BFD interval. That's how it goes. How often? 50 is the minimum.
No, that's go ahead and type it. Yeah, it's easy.
That I'm going to say minimum, meaning this is probe sending and this is probe receiving. And the given time to identify the neighbor is error loss is 150 seconds. So I'm saying multiply by 3. Now BFD is applied here. Let's go to 102 and verify 101 and verify neighbor. There is no neighbor. Why? Because it needs to be attached with a routing protocol. It can work with any routing protocol. What we have is OSPF. So I'll go back again to the interface. As I said, it can be enabled globally by going under OSPF, or it can be enabled per interface. So I'm just going to put one command IP OSPF BFD. That's all. I'll also put the same on the other side. Okay, you want me to remove this? Okay. So I removed it.
One moment.
Now you will see that, but it won't be up.
No, before.
Okay. Do show BFD neighbor. You see, administratively down because the other side is not.
And then go to 101.
Configure. This is the IP address of the
I know,
other
that's
guy.
what I want to see.
So let us go and enable. Now I'm expecting the neighbor is up. You can also type the neighbor detail command. Now you can see more information. You see multiplier of 3, received time in millisecond. Yeah, and then it's up every 50 millisecond. The interval, the time, the version so far. All right, so it looks good. The BFD is working fine. Now it's a testing time. Listen, this one is still pinging. I can stop this ping. How do we stop this? Okay, I can trace route and show you it is still going via the upper switch 101. Now let me try pinging again. It is pinging, and I'm going to shut down like before the 201. Okay, 201, I'm going to shut down. Is it 201 or yeah, 201? I'm going to shut down like before. Now you see BFT immediate. You see, it didn't take much time. How many packets you lost? 3 packets. Not much. BFD makes this convergence faster. That 3 packet also you might have not lost if you would have enabled this part. It would have just gone like this, not like this. Yeah, you know why 3 packet? This need to inform this guy, and this guy should decide not to send this way, but to send this way. That is why 3 packets. Otherwise, that 3 packet also would have not been lost. Now let's discuss something, and then we'll come back. So we want this to be the primary path, this to be the backup.
Right.
For that, when I summarize and send, I'm going to summarize this all 10.1. blah 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 to 10.1.0.0/16. And while summarizing, I am going to set cost for this path as 150. And this one, I will not set any cost. It will be the default cost, which is 10. By doing so, we can have primary and secondary. The primary path will be the above path because of the less cost. Right now, if you go to VPC 6 and trace route to 10 to 80.8, do you locate this? 10 to 80.8? 10 to 80.8. It is going via the below path. You see? It's going via the below path. But we do not want that. We want always the upper path to go and come. So I'm going to summarize and make the difference. Let's do that. I'm on switch 101. And I need to go under the area for summarizing. Sorry, OSPF. Router OSPF1. Area 1 range command. This is how ABR summarization goes, isn't it? 255.255.0.0. And I'm not setting any cost. I'm just leaving default for the summary. Whereas on the below switch 102,
Right.
router OSPF1, area 1 range command 10.1.0.0 cost. I'm going to say 150. So now if you go and check this router 12, router 12 will be taking only this path for all 10 router 12 here. Show IP route OSPF. You see, you got a summary route and it is pointing towards why is it like that? Show IP OSPF neighbor. Okay. I think I did not bring that interface up. That's why. The early, see, it is still shut down. You understand? Okay. Now, if you see the summary 10.1, okay, gone. Okay, it is going via the upper path only. You got it? Okay. Now, what is next? We have summarized and we have set the cost while summarizing. That's all we have achieved. We have achieved. If this goes down, see right now the cost is what? 30. If I shut down, only then it will come via the other path. The cost will be very high. You see, 170. Because BFD is in place, it is very fast in convergence.
30.
When failure happens, it will be fast. Now to go back, it will take time because we did not configure BFD node. The bottom or this is OSPF timer. Hello packet should come. Line protocol also should come. Okay, now that is all. That's all. That's all. Okay. So what all we have seen? We have seen first we have seen authentication using SHA-384 for which we need keychain. We used a keyword called cryptographic algorithm. Let me show you. Show run section
keychain.
Chain. Cryptographic algorithm. And then we called this under the interface. Show run interface Ethernet 0/0. You can see it here. And then we enabled the BFD timer as per the requirement. Error should be confirmed at 150 millisecond. And probe should be sent every 50 seconds and probe should be received every 50 seconds. And we are tying that BFD to OSPF. All these are under the interface. At last, we did the summarization with the cost. Because we want the upper path to be the primary, we did not set any cost. For the below path, when we summarize, show run section router OSPF. Here we don't have any cost added, whereas on switch below 102, we got the cost. As a result, all the traffics are going to go via the upper path as long as that upper path is alive. As soon as the upper path goes fail, the BFD is in control to immediately swap it in less than 150 millisecond. Right, if alternate path is available. Because we have alternate path, it will be fast. We tested without BFD as well as with BFD. We saw the big difference. It was really a big difference.
Right.